Today is the Chapter 9 review preparing for our upcoming test. Our warm-up for the day is this. Here I have a house, and I want to paint my house. I'm going to paint this whole house. But do I paint the door of my house? No. Am I going to paint the window of my house? No. So I have to paint everything except for those two figures. I'm not going to be painting those. So we need to figure out how much we are going to paint. So we're going to be finding the area of several shapes. How many shapes are we going to be finding the area of in total, Rocco? Not 2 shapes. It's a good guess, Hannah. 4 shapes. We're going to be finding the area of 4 shapes. Exactly. Yes, Rocco. We're going to be finding the area of the roof, the wall, the door, and the window. We're going to be finding the area of all 4 of those shapes. But we don't care necessarily. We're not going to be counting all of that. We might not be adding all of those together. We might be subtracting some of those from it, which would leave us with 2 shapes. First, we're going to identify each of the 4 shapes that we're going to be finding the area of. So we have this shape up here. We have our triangle. We have the shape here. We've got this rectangle. We've got this shape here. We've got that rectangle. And then we've got that shape right there, that bottom rectangle. So first things first, Melanie, can you tell me the area of the window? 12. Excellent. Area of any 4-sided shape that has parallel sides, both parallel sides, is area equals base times height, and or you've heard it as length times width. This unit, we're just calling it base times height to make it a little easier. Alinza, what is the area of the door? 24. Excellent. Once again, we just multiplied that 8 times the 3. Excellent. Lucy, what's the area of that triangle? You got 25.
Oh, no, 45.
Oh, 45. I was going to say, thank you. Perfect. So she got the area to be 45. How did she get that? Lucy, how did you find that? Excellent. You have to multiply base times height and then divide it by 2 or multiply it by half. Same thing, remember. X times half. We do our keep, change, flip. X, change, flip. Those are the exact same thing. Multiplying by half, dividing by 2 are the exact same thing. Our height here was 6. Our base was 15. We add that 1/2. I want to get rid of that half. I turn it into a 3, and I get 45. Excellent. And then lastly, Malia, what is the area of that whole house rectangle?
180.
180. Excellent. Once again, we just multiplied 12 and 15. Awesome. So now I'm going to add all of these together, right?
No.
No.
Oh, you gotta
What do I have to do, Rocco?
subtract the door and the window.
Yes, I have to subtract the door and the window because they're painted already. We're not painting over them. So what are the 2 shapes I am adding together, Jaden? So Jaden says I'm adding together the door and the window. Yeah, that works because we need to know how much that is to take away. If we add that together, we get 36. What else do I have to add together then, Romario? Well, what are the shapes I got to add together? The house and the roof. And what's the answer to that? To the house and the roof, Romario?
225.
Perfect. 225. And because we've already painted that, we're going to be taking the 36 away. We're taking that door and that window away. So, Emerson, what is 225 minus 36? 189. Excellent. So the total area of the house that we have to paint is 189. If I had mentioned it, it might be feet. That would become feet squared. If it was inches, whatever it is. Whenever we're doing the area, it's squared. Area is the squarea. So, here. Now, I want to find the total area of these figures. So these are overlapping figures right here. And I want to find the total area. Miles, the first things first is we want to find the area of one of our shapes. We're going to find the area of the one that I just made orange. What's the area of that shape?
10 times 11.
Perfect. You did 10 times 11, and what'd you get?
I got 110.
Perfect. We get 110, 10 times 11. Excellent. Now we want to find the area of this shape. So Tobias, what'd you get as the area for that shape? 156. So now we found the two areas, and we just add them together, right?
No. Yeah, but then you have to find.
Well, we got to do something else, too. What do we have to do, Ben?
You have to find the area of the middle one and then subtract it from the total area.
Yeah, we got to find the area of this middle one and subtract it. But this middle one, I don't know any of the sides. How am I supposed to do that, Anita?
10 minus 6.
Perfect. So one of them I'm going to do 10 minus 6. This whole length is 10 right here, which means this whole length is 10 right here. But part of it is 6. So the other part has to be, Daniel? 4. Exactly. So we get this side to be 4. What about on this other one here? This other one, Ben?
It's 6 because the 11 on the top and the 5 on the bottom is 11 minus 5.
Excellent. Since it's going to be 6 because there's the 11 on the top and a 5 on the bottom. And the difference between the two of those is 6. So then, Hannah, what's the area of that inner triangle or the inner rectangle?
24.
24. Excellent. So these kind of math should be easy because it's basically just squares and rectangles, which the area is just simple multiplying. So now I'm going to add all three of these together. So I'm going to add 110, 156, and 24, and that's my answer, right?
No.
No. Why not, Gore? What's my problem? Yeah, I have... So, do I subtract 24 from each? What do I do, Rafi? Yes. So I only subtract it once, not from each. So here I add 110 and 156, and then I'm going to subtract that 24, and it's going to give me my ultimate answer. So Romario, what's 110 plus 156? 266. And then what do I get, Romario, when I subtract 24? 242. Excellent. Now, once again, if these were inches, it would be inches squared. If it was meters, it would be meters squared. If it was feet, it would be feet squared. Area is the squarea. What about this shape? What is this shape called? Lucy, what is this shape called? Yes, it is a composite figure. And we know it's a composite figure because does that look like any shape we've ever seen? No. This is a composite figure. Composite figures are composed of more than one figure. So what is this one composed of? What two shapes? Elsie?
A square and a triangle.
Perfect. So it's going to be a square and a triangle. Yeah. Technically, squares are rectangles, so it's fine. So we got our square and our triangle. Square and our triangle. So now we need to find all of the answers for this. Now, I want to break it apart into two pieces just so that we can see it better. I'm going to show us. We're going to separate it into two pieces so that we can see it better. The first one that I've got is I have my triangle. And the second one I have is I have my square. My square, I know that one side is 5.2 and the other side is 5.2. With my triangle, I know my height is 7. But what is my base? How do I find my base? I don't know what my base is. It doesn't tell me. So Fernando, how do I find the base? Perfect. So Ben pointed out that we have to add up 4, 5.2, and 2 because that's the length of that whole base. So 4 plus 2 gives us 6 plus 5.2 gives us 11.2. So now we're able to find the area of both of our shapes. Anita, what did you get for the area of the square? 27.04. Excellent. She multiplied together 5.2, 5.2. The easy way to do this, you move your decimals away. You end up getting 4010026. You get 4072, and we have to bring it back 2 times to get our 27.04. Excellent job, Anita. Fernando, what did you get for the area of your figure?
39.2.
Perfect. 39.2. In this case, we do the exact same thing. It is 7 times 11.2. But because it's a triangle, we also have to multiply it by half and or divide it by 2. So when we do that, we get our 39.2. But that's not our final answer. What does our final answer need to be then, Gore? 27.04 times 39.2. Do we agree? No. Plus. And when we add those together, we're going to get 66.24. Excellent. Here we have this shape. It's also composite shape, just like we know it's made up of 2 or more shapes. There's multiple ways we can divide this. The easiest way is to split it into our rectangle. Ignore my bad stuff. It's supposed to be more of a rectangle. And a triangle. If we want to make our lives really difficult, we could split it up into a trapezoid and then a triangle here. But that makes our lives really tricky, and we don't even know how to do that because we don't know what this length right here is. So instead, we're going to make our lives easy, and we're going to split it into that triangle, pretend it's a better triangle, and that rectangle. So this triangle, what is the length of the base of my triangle? Hannah? 16.4. Exactly. This bottom part is 16.4, so the bottom part of our triangle has to be 16.4. And we have the height of our triangle, and we have the height of our rectangle. Elsie, what'd you get as the area for the rectangle? 114 and 8/10, and we're gonna just call it inches squared because I just put the inches because it's the easiest. Great job. We multiplied our base times our height. Excellent. Oswaldo, what do you believe then the area of the triangle is? He says the area is 90 and 2/10. There's one step he didn't do. What is the one step, Lily? He needs to divide by 2. So what did you get, Lily? 45 and 1/10. Excellent. For this one, I just want to show you my easy one. We have 1/2 times 16.4 times 5.5. I like to cancel things out. So that 1/2 and that 16.4, they're both even. That's going to go away, and I'm going to get 8.2. I get 8.2 times 5.5, and then my answer is 45.1. Now, am I going to be subtracting anything?
No.
No, because there's no overlap, there's no anything like that. So I just add them together. Who'd like to tell me the answer? Romario.
159.9.
Excellent. 159.9. That's our area. Now here's a question for you. Here's that same shape. But what factor does the area change if each side is doubled? What factor does the area change if each side is doubled? I'm not asking you to find the new area. I'm saying how much does it increase by?
2.
Gore?
6.
Gore says 4. Daniel said 2. Ben, what do you say?
Size double. Wait, come back to that.
Miles, what do you think?
Increases by itself.
Increases by itself. What else? Do we have anything else? We've got 4, 2, itself. Daniel again.
I got 2 and 6.
2. He also says 6.
I got 4.
Rocco got 43. It's not that. I'll tell you. The correct answer is
6.
4.
Oh my God.
It increases by 4. Gore, how'd you get 4? Exactly, because it's the area. We're doubling everything, and with area, we're multiplying our base times our height. It's 2 times 2. It becomes 2 times 2, or 2 squared, and that's 4. Okay, but what if each side is multiplied by 1/3? What do you get, Hannah? 1/9. Again, same exact thing. With area, if each of our sides are multiplied by the same thing, which it is, it's just going to be the same thing squared. We did this proof before. We did this proof where if I have one side is 2 and one side's 3, I multiply each side by a factor of x. My original area was 6. My new area is 2x times 3x, which gets me 6x squared. So when I multiply my side by x, I go up by that x squared. Here I've got this chart. I've got 3 different shapes, and I want to find the area and or height and or base of each shape. We already know that area is equal to base times height. Equal to base times height. Area is equal to base times height. So we already know that. Now Daniel likes to make them into decimals. I like to make them into improper fractions. Who's right? Yeah, technically the answer is both and nobody, because either way works. So just like we did in our 3 chapters, chapters 6, 7, and 8, we're going to make these into equations with our variables. So no, we don't know our height. So it's going to be 15 3/4 times x is equal to 147. Whenever we have a variable, what do we want to do to that variable? What do we want to do, Michelle? Isolate it. So how would I isolate this variable then? How would I isolate it? Rocco.
X equals 147 times 15.
So he says x equals 147 times 15 3/4. What do you think, Hannah?
I think we would divide that 15 3/4.
Yeah, we're going to be dividing because this side is multiplying right there. So we're going to divide each side by 15 3/4. We're going to be dividing each side by 15 3/4. So I like to do it, like I said, as an improper fraction. So I've got 147 divided by, and to make it into an improper fraction, I have 15 3/4. 15 times 4 is 60, plus 3 is 63. So I get 63 over 4. But I don't want to do it like this. I want to Kentucky chicken fried it. So we're going to turn it into keep, change, flip. It's going to be 147 times 4 over 63. Now, here's another hint for you. I want to do as little work as possible. So I want to cross-cancel things. I want to cross-cancel some things. I already know I can't cross-cancel 1 and 4 because it's already at a 1. But let's think about 147 and 63. There's all sorts of factors that we have of these numbers. You could go down your factor list. So for 147, we have the factors of 1 and 147. It's not even, so we don't have 2. Let's try 3. When we divide 147 into 3 groups, we get 49. It's not even, so 4 is not going to work. 5 is not going to work. 6 is not going to work because in order for 6 to work, you have to have both 2 and 3. In order for 6 to work, you have to have both 2 and 3. Let's try 7 then. If we divide 147 into 7 groups, we get 2, 1. So we get 21. And I'm still noticing something. That means we've got some nice big old factors here of 21. Is 63 divisible by 21?
Yes.
Yes. So we're going to cancel out each of these and divide them by 21. 147 divided by 21, we got 7. Then we've got 63 divided by 21, we get 3. So now we get 28 over 3 as our answer because we've multiplied across. But now I want to simplify this into a mixed number. What do you get, Ben? Hannah. Perfect. 9. I'm going to write it in red so we can see it. 9 and 1/3. We make it into an improper or mixed number. How many times does 3 go into 28 without going over? It goes in 9 times. That's 27. What's left over is 1. So we get 9 and 1/3. We do that same exact thing for the next problem. For this next problem, we now have x times 11 and 1/4 is equal to 140 and 5/8. I'm going to divide each side by 11 and 1/4. But I want to make it into my improper fractions. Who can tell me what 11 and 1/4 is as an improper fraction, Rocco? Who can tell me? Michelle. Perfect. 45/4. 11 times 4 is 44, plus 1 is 45, and our denominator stays the same. So we get 45/4. 140 eighths. 140 and 5/8. This one's quite a lot. 140 times 8, we get 1,120, but we've got to add that 5, divide by 8. So now we are dividing by 45 over 4. But yet again, I don't want to do this. I want a Kentucky Chicken Fried this. So I'm going to turn this into times, and then I'm going to turn it into 4 over 45. Now let's see. Can I cross cancel? I'm not sure what that did. So can I cross cancel? Okay, I'm not even going to bother trying to move that. What can I cross cancel first, Ben? 4 and 8. This becomes a 1. This becomes a 2. We already know the other one is divisible by 5, both of them, because they both end in a 5. But we can see if they are divisible by more. If they're divisible by 5, we might as well try 45. Let's see, we can hope for it. 1,125 divided by 45. 0 times, 0 times, 2 times, which is 90. We subtract that, we get 22. 5. How many times does 45 go into 225, Rafi? 5 times. So we get our answer here, 25 over 1. So our answer becomes 25 times 1 is 25. 2 times 1 is 2. So we get our answer to be 25 over 2. And who can tell me what that is as a mixed number? Malia.
12 and 1/2.
Perfect, 12 and 1/2. Exactly. 2 goes into 25 12 times without going over, following our Price is Right rules. And then we have 1 left over. Great job. This last one is really, really easy. We have 10 and a 4th. That's going to be 41/4. We have 14 and 3/4. That's going to be 59/4. And we're going to get it equal to something. We can't cross cancel anything. We already know that because 4s and 4s are even and the other ones are not. So we get over 16. And just because we want to go fast, 41 times 59, we get 2,416. Now these ones, they're both even, so we know we can divide these by at least 2. So I'm going to get 1,208 over 8. Again, these are both even, so I can divide them yet again. In fact, I actually look at this. These are both divisible by more than just that. 1,208. You can divide it by 8. So when I have 8, 1,208, it goes in 0, 1, 8, 4, 0, 5, 41. So we get our answer to be 151. Emerson in the back is right because look, this is supposed to be a 9. So I accidentally had 3 more than I was intending on. I accidentally had 3 more of the 16 because I thought it was 6, which leaves us with 3/16. That was just a multiplication error on my part, but the thing is that if you do that, you just start solving, you just get the answer. And we find out that our answer is 151 3/16. First of all, here's my trapezoid. We know it's a trapezoid because it has 2 parallel sides and then 2 not parallel sides. What is the formula for area of a trapezoid, Ben?
1/2 height times base 1 plus base 2.
Excellent. 1/2 times height times base 1 plus base 2. So we're going to fill this in. What's our height, Elsie?
3.
Our height is 3. What's our base 1 then, Andrew? Our base 1 is 5. Based on that, what is our base 2 then, Rafi? 10. Excellent. So now we're going to have this be 1/2 times 3, and 5 plus 10 is 15, times 15. So in this case, there's no even numbers. I can't cross cancel, or I can't multiply anything out. 3 times 15, we get 45 divided by 2. 40 divided by 2 is 20. 5 divided by 2 is 2.5. So my end answer for my area is 22.5 or 22.5. Liam, what is the area formula for a triangle?
You multiply the height and then you divide by half.
Perfect. So we've got 1/2 base times height. Excellent. Jaden, what's the area for a rectangle? What's the formula for a rectangle? Base times height. Excellent. Gloria, what's the area formula for a trapezoid?
1/2 h plus base 1 plus base 2.
Perfect. 1/2 h times base 1 plus base 2. Excellent. Now, if we had this, I want to find the length of each side. What is the length of this side here? What's the length? Rocco? 5. Excellent. What's the length of this side here? Gloria? 3. What's the length of this side here, Ben? 5. And then what's the length of this side up to here again? Hannah? From 5 to 2?
Oh, 5 to 2. 3.
3. Excellent. We know that we're going to make some sort of rectangle where technically our rectangle is this. Our y is 5 and our x's are 3 on each side. Sometimes you might not be given a rectangular shape. You might be given a trapezoid. You might be given a triangle. These are called the vertices. Always check between the two. Draw it and check between the two.